This is a 2D example predicting, again, what the gentleman from Hanover was talking about yesterday, the formation of serrated chips and the shear banding. This is some work that's being done in Italy. But as you vary feed, with everything else held constant, on a higher feed, 1/4 millimeter, we are getting a serrated chip, which agrees well with the experiment. As we back our feed off to 1/10 of a millimeter, same cutting speed, we transition to a smooth chip. Another issue is, how does a chip break? If we use a chip breaking insert, curl the chip back into the workpiece, do we actually get something that folds over, or do you just get something that coils up on itself or becomes long and stringy? This is still a real new area. The ability to make a computer show this is one thing. The ability to tell the computer when is that chip going to break for a given material, does it break or does it coil, that's still really an area that needs a lot more work. So right now this makes a nice animation, but we really need more knowledge, and there needs to be more fundamental work done to understand when this is going to happen and when it's not going to happen. I showed this simulation earlier of the spiral chip forming. One thing that we didn't really look at the end of that simulation is what happens when the chip exits. And if you watch this animation, you see right along here there's this shear band that's occurring as the material sort of goes from being part of the workpiece and shears up in to form the chip. And you can see that as it exits, that rotates around and you get the beginning of a burr formation here. Now we, again, don't have the technology to completely separate the chip at this point, but you can get an idea of how you're starting to get an exit burr forming at the end of a part.